Hello students, welcome back to the 8th video of this playlist. So in this video we will be solving the last question of P4 October 2023 paper, that is question number 8. Okay, so let's see question number 8. Basically question number 8 is from differentiation and integration, a mixed type of question from both the chapter number 6 and chapter number 5 of your P4 textbook. So in order to be able to solve this question, you should have clear idea about those specific topics, that is parametric differentiation and volume under revolution, and besides you should have idea about integration by substitution method. Okay, so let's get started. Okay, so you can see in question number 8 there is a parametric curve has been sketched. The sketch of parametric curve C is given. So the parameters for this curve, that is x is given, the parameter for x is given, the parameter for y is given there, the range of values of t is also given. Fine. The curve meets the y-axis at 2 and the x-axis at k. It meets the x-axis at k, where k is a constant. So we need to find out the value for k. So what would be the value for k? So definitely you can figure it out, because at point k the value of y is what? 0. So basically the range of possible values for t is given. So when the value of t is 0, we know that for t is 0, cos 0 is what? 1. So we got 2 there. And if you put pi over 2 into the place of t, you will get cos 90 degree, that is 0. And that is what? The point k. So basically at point k, t equals to what? Pi over 2. We got at point k, t is equals to what? At point k, t equals to what? Pi over 2. So if t equals to pi over 2, what would be the case? What we can write? Put it in the equation of in the parameter of x, you will get what? 6 pi over 2, that is pi over 3. Okay, that is x equals to k, that is the k, it is equals to what? 6 pi over 2, right? That is 3 pi minus what? Minus 3 sine 2t. So sine 2t means what? Sine pi, sine 90 degree, sine 180 degree. Pi radian is 180 degree. So sine 180 degree is what? 0. So it is just 3 pi. The value of k is what? The value of k is 3 pi. Okay. Next, part B. What they have asked in part B. Use parametric differentiation to show that what? To show that dy over dx is equals to lambda cosec t. Okay, let's do this. For part B, we need to use parametric differentiation. So in parametric differentiation, what we do actually? We differentiate the x parameter and the y parameter what? Simultaneously. So dx over dt, and on the other hand you will get dy over dt, right? Okay, so let's differentiate the x parameter. So if you differentiate the x parameter, what you will get? Derivative of 60 is what? 6. So that would be just 6 minus what? Sine 2t. The derivative of sine 2t is what? 2 cos 2t. That means 3 times 2, that is 6 cos twice of t. Fine? Cos twice of t. Fine? Okay. And the derivative of y parameter is what? Negative 2 sine t. Negative 2 sine t. Negative 2 what? Sine t. Done. We got the derivative of the two parameters. Now we need dy over dx, right? Dy over what? Dx. So what would be dy over dx? Dy over dx would be dy over dt, that is negative 2 sine t over what? 6 times, take 6 common, you will get 1 minus cos 2t. And 1 minus cos 2t, if you want to like simplify it more, then cos 2t can be simplified using, not simplification, you can say it can be expanded using the double angle formula. Cos 2t can be written as what? 1 minus 2 sine squared t. So 6 times 1 minus 1 plus what? 2 sine squared t. Minus minus, it will become plus. So plus 2 sine squared what? T. Okay. So definitely you can understand like why I am expanding it using double angle formula, so that I can have the same trigonometric ratio in the numerator and the denominator. So we'll get negative 2 sine t over what? Negative 2 sine t. So we'll get 1 minus 1, that is what? 0. So 6 times 2, that is 12 sine square t. So 12 sine square t, and on the numerator it would be what? Negative 2 sine t, right? Okay. So what would be the value? You will get what? Negative, okay, you will get negative 1 over 6 sine t over sine square t, that is 1 over sine t, that is cosec t. That's it. So the value for lambda is what? Negative 1 over 6. Fine. Next, we are done with the parametric differentiation. So let's move on to part C. Okay. So in part C, they said the point P with parameter t equals to pi over 4 lies on C. Okay. So the parameter for t is given. Using that parameter, we can find the value for x and y. That is the x and y coordinate of point P. The tangent to C at the point P, cuts the y-axis at the point N. Fine. The tangent that is drawn to the curve C at point P, it cuts the y-axis at the point N. So now they asked, find the exact y coordinate of N. The exact y coordinate of N, giving you answer in the simplest form. Okay. So we need the equation of tangent at first, right? So how can we figure out the equation of the tangent? Since the parameter is given, we will use this parameter to find the derivative, that is the gradient of the curve at point P, and using that parameter we will also find the x and y coordinate of point P. So let's do that. T equals to what? Pi over 4. T equals to pi over 4. So there is pi over 4. So if t equals to pi over 4, what would be the x coordinate? Pi over 4 is what? 45 degree. So 6 pi over 4, that is 2 pi, 3 pi over 2, right? Exactly. That would be 6 pi over 4, that is 3 pi over 2. So 3 pi over 2 minus what? 3 pi over 2 minus what? It would be sine 2t, that is sine 2 pi over 2 pi over 4, that is sine 90 degrees. Sine 90 degrees is what? 1. So you will get x equals to 3 pi over 2 minus 2. Fine. So we got the x coordinate 3 pi over 2 minus 2. Let's have a check. Sine 2t is 2 pi over 4, that is sine 90. Oh, it is negative 3. It's not negative 2. It would be negative 3. And now let's find the y coordinate. Y would be what? Y would be 2 cos t, that is root 2 over 2, right? cos 45 degrees is square root of 2 over 2, that is just square root of 2. So we got the coordinates of point P, that is 3 pi over 2 minus 3 and square root of 2. Fine, we got the coordinates of point P. Okay, next is we need the gradient, right? The gradient of the curve. So basically the gradient of the curve is the same as the gradient of the tangent. So put the parameter into the equation dy over dx. Negative 1 over 6, there is negative 1 over 6 cosec t. So cosec pi over 4. Cosec pi over 4 is basically 1 over sine pi over 4. There is 1 over square root of 2. That is square root of 2. Cosec pi over 4 is square root of 2. So that means negative what? 1 over 6 times square root of 2. That means it is what? The gradient would be negative square root of 2 over what? 6. That's the gradient of the tangent. So let's find the equation of the tangent. So what would be the equation of the tangent? If you want to find out the equation, what we will use? Equation, what would be the equation? So equation would be what? Y minus y1. We know a point and also the gradient. So y minus square root of 2 equals to what? M. The gradient is what? Negative square root of 2 over 6 times what? X minus x1. So x plus 3, right? Minus 3 pi over 2. 3 pi what? Over 2, right? Okay. So this is the equation of the tangent. Now they wanted the coordinates of n. The y coordinate, not the coordinates, only y coordinate. Okay. So at y coordinate, like point n, it is cutting the y axis. Okay. So at point n, what we can write? At point n, we can write x equals to 0, right? At n, what? X equals to 0, since it is intersecting the y axis. So x equals to 0. So if x equals to 0, then what would be the case? Y minus square root 2. Okay, 1 minus square root of 2, it is equals to what? X is 0. So you will get negative square root 2 over 2, because as you multiply it with 3, okay, and then plus what? 3. Okay, 3 gets divided by 6, so you will get just square root of 2. Square root of 2 over what? 4. Because 3 divided 6, there is a 6 divide 3, that is 2, so 2 times 2, that is 4. 4 pi. Okay? And then we need the exact y coordinate, so we don't need to what? Put any decimal value here. Okay? So we'll get square root of 2 over 4. Square root of 2 over 4 pi, and then minus square root of half, like minus half of square root of 2 plus square root of 2, that is what? Plus half of square root what? 2. So that we'll get square root of 2 over 2. That's the y coordinate of point what? N. Done. Okay, next. Part D. Okay, in part D, what they have asked, the region bounded by the curve, the x-axis and the y-axis is rotated through 2 pi radians. Okay, about the x-axis to form a solid of revolution. So part D asks to show that the volume of this solid is given by this equation, and then we need to find out the exact volume of this solid. This is for 6 marks. So we need to find out the volume under revolution, right? So for finding volume of revolution, how can we do that? We need to use what? Integration, right? So we know the value for k, right? The value for k was 3 pi, and we also know the value for what? This point, that is the origin. Okay, so we need to integrate. We need to use integration definitely. So let's move on to the next page. Okay, for part D, volume of revolution, right? So volume, we need what? Volume. Okay, for finding the volume, what we need to use? Integration pi times what? Integration of y square dx. Integration, the upper limit is 3 pi and the lower limit is what? 0. y square dx, right? This would be the equation. Now we need to use integration by substitution here. Okay, since we like the curve C is a parametric equation, so we will substitute the parameters. That means we have to convert the terms xy to t. Okay, so we know the y parameter, that is y equals to what? Y equals to, it's given in the question, 2 cos t. Y equals to 2 cos t, that is given in the question. So we got the substitute for y. Now we need substitute for what? X, right? So x equals to what we know? 60 minus 3 sine 2t. So x equals to 60 minus what? 3 sine 2t. Okay, so this is the parameter for x. Okay, now we need a what? Substitution for dx, right? So differentiate x. Dx over what? Dx over dt would be what? Dx over dt equals to what? 6 minus 6 cos what? Cos 2t. Fine? Cos 2t. Fine. Now what we need to do? We need substitute for dx, right? So make dx subject from there. So what you will get? We can make 6 subject from there, right? We can make 6 subject from there. Okay, so you can write 6 times 1 minus cos 2t, right? 1 minus cos 2t. Cos 2t. So cos 2t can be written as what? Okay, before simplifying cos 2t, let us see what would be the substitute. Like, let us substitute at first y squared. So integration of y squared dx can be written as what? Y squared dx would be equal to what? Integration y square is what? In 4 cos square t. Okay, 4 cos square t. So take this constant 4 outside. So 4 cos square t and what? Dx, right? So in place of dx, you can multiply it by what? 6, right? So 6 times 4, that is what? 24. So 24, and 1 minus cos 2t can be written as what? You can write 1 minus cos 2t as 1 minus, we can convert it to, let us convert it to sin t. Okay, I will tell you why I am converting it to sin t. Okay, so cos 2t can be written as what? 1 minus 2 sin square t, right? So 1 minus 1 plus 2 sin square t. Okay, we could also convert it to cos square t, but I didn't do that. There's a reason, you will soon understand. Okay, so it should be dt there. Okay, so dt would be there. Okay, so what we can do, 1 minus 1, that is what? 0. So we can write, take a 4 inside the integral. So if you take 4 inside the integral, you will get 6 integration 4 what? 4 times, or 1 minus 1, that is what? 0. so you don't need to take 4. Okay, we can take I think you can figure out like why I took sin squared t instead of cos squared t. 2 sin squared t is already there, so we need a 2 inside the integral in order to convert it to what? Trigonometric double angle formula. Okay, so cos squared t is there. We can see cos square t, so 2 times 2, that is 4 sin squared t cos squared t, right? 4 sin squared t cos squared t. Okay, because we know that sin 2t can be written as what? Sin 2t can be written as 2 sin squared t cos squared t, right? So that would be what? We can write here 12 integration. We can write sin squared t cos like 2 sin t cos t. Yeah, 2 sin t cos t is what? Sin 2t. So this is basically sin what? Sin 2t whole squared. Okay, sin 2t whole squared. Sin 2t whole squared dt. Fine. So we got a simplified integral, right? Simplified form of the integral. Okay, now what we need to do, we need to put it in the equation for the volume. We got the volume v equals to what? Pi. I didn't consider pi earlier, so it should be what? 12 pi. Okay, 12 pi, and we need to change the what? Limits. Why? The previous limits were for x. Okay, but now since we are considering t, we need now the limits for what? T. So in that case, what was the limit? The upper limit was pi over 4. Sorry, pi over 2, right? At point k, it was pi over 2, right? Yeah, it was pi over 2. So the upper limit would be pi over 2 and the lower limit would be 0. Let's figure it out. Yeah, it will be 0. Okay, so pi over 2 to 0. Pi over 2 to 0. Okay, like we are just finding the corresponding values of t for 3 pi and 0 using the x parameter. Okay, we are finding corresponding value of t. Okay, so sin 2t, that is sin squared 2t dt. We got sin squared 2t dt. Is this fine? Fine. Okay, so what we can do now is that we can integrate sin squared. Okay, let me see what we need to do actually. 1 minus cos 4t. That means we need to represent sin squared 2t in the form of cos squared t. Cos 4t. So how can we do that? Look, cos 4t can be written as what? Cos 4t can be written as 1 minus 2 sin squared 2t using trigonometric double angle formula. Okay, okay. Now from there, if you just make sin squared 2t common, you will get a substitute for sin squared 2t. That's it. So sin squared 2t would be what? Sin squared 2t would be half. That would be what? Half minus what? Half minus half of cos 4t. Yeah, exactly. Half of cos 4t. So we got the substitute for what? Sin squared 2t. Now just put it in the integral. We will get the what? We will get the limit. We will get the integral as per asked by the question. 12 pi, the upper limit is what, pi over 2, the upper limit is pi over 2, and the lower limit is what, 0. And sin square 2t is what, half. We can take half common, right? If you take half common, half will get multiplied with the 12 pi outside the integral, okay, and then it will be 1 minus cos 40 dt. Fair enough. Okay, so half times 12 is what, 12 pi. This is 6 pi integration from pi over 2 to 0, 1 minus cos 40 dt. Fine. That's it. So does match the given. It should be beta. Okay, beta should be inside. Okay, inside the integral. So 6 pi would be inside the integral. So we will get what, integration from pi over 2 to 0, 6 pi times 1 minus what, 1 minus cos 40 dt. That's it. So that means the value for beta is what, the value for beta is 6 pi. The value for beta is what, 6 pi. 6 pi. Done. Now what we need to do, this is for part 1. Okay, part question D is basically divided into 2 parts. This is the first part. Now in part 2 we need to just integrate and find the exact value. That's it. So what would be the integration? 6 pi, take 6 pi outside the integral, okay, and then do the integration within the definite integral. So we'll get t, integration of 1 is what, t, and negative cos 40, right? So integration of cos 40 would be sin 40 definitely. And if you, this is a reverse chain rule. So 40, differentiation of 40 is what, 4. So use this derivative to divide the coefficient. It was negative 1. So negative 1 over 4 sin 40. Upper limit is pi over 2. The upper limit is pi over 2. And the lower limit is 0. So what you will get? This is the volume V. Okay. So 6 pi, the upper limit is, put the upper limit, that is pi over 2. So pi over 2 minus what, 4 pi over 2, that is 2 pi. Sin 2 pi is what, 0. 0. So it is just pi over 2. That's it. Okay, because pi over 2, it's just pi over 2. Then sin 4 times pi over 2, that is 2 pi, that is 0. Sin 2 pi is 0, right? And then the lower limit is what, 0. So t is 0, and again sin 0 degree is what, 0. So 6 pi over 2. So we will get the value for volume. It is 3 pi squared, the exact value. 3 pi squared what, unit cube. That's the volume of the formed solid. Okay, and that's basically the end of this paper, and also question number 8, the last question of this paper. So if you have seen any mistakes in my workings, then definitely feel free to tell this in the comment. I'll be definitely go through this problem again. So hope you understood the whole paper very well, and that's all about this paper. Thank you.